Hi, how's it going, guys? Like many of you pilots, I use these Quaddiction 5x5 pop-up gates from Ready Made RC. The only problem, I'm not sure if you guys have noticed after a while of taking a few impacts, we can see that there's some parts of the actual gate that start to wear out. For example, I'm talking specifically about these bolts and the sleeve. What we find is sometimes when we smack the gate, we find that we might break these bolts and then the sleeve slips out, and then you end up just after every hit of the gate with your quad, you end up poking this shaft back into the holder. So Ready Made RC does sell the complete gusset, bolt and sleeve assembly for you to pop in, but in some cases all you really need are those bolts. Usually the sleeve is intact, you can just pull that out and glue it back in with hot glue or some non-permanent adhesive, because you actually have to be able to take that sleeve off to put a new bolt in. So I'm just going to show you a method I used in order to replace this bolt by using a 3D printer. The idea is that we don't already have a bolt that exists as a drop-in replacement. So what I do is I go to my first port of call, which is Thingiverse. From Thingiverse, I look for, say, maybe Quaddiction Gate, FPV Gate. Do we see? No, we have no results for that. So what can we do? So the other thing is we might want to find, say, a donor bolt that we could scale and modify to suit. So I'll look for any type of bolt, and then we start to look around and we start to see, well, do we have some that could fit the bill? So from my previous experience, I chose one basically at the top of the list. This knurled bolt and nut by Akira 3D P0. So shout out to him, and you could give him a donation if you decide to use this bolt as well. So what we do is we download these files like so, and you usually download a zip file, and then we open up the part, we go into, we load your preferred 3D printer G-code converter, and then we drop in the bolt. Depending on the choice. Let's just take this 20mm bolt. Let's just take the very first file we come across. So when we have this, we'll drop in the object. So initially I recommend to print this. Now the reason I prefer to print a blank is that regardless of the dimensions on this STL file, regardless of what they measure out on the CAD program, your 3D printer is going to have its own nuances. It's going to round off certain figures, the G-code is going to convert certain figures, and then depending on how much your how old your filament is, how much your nozzle is worn, or what the tolerances are in your machine, or how well you built the machine, you might end up having slight variations. So we end up with something as I show here. This is the bolt that I have printed. So the idea is now that we scale the bolt based on one, the diameter of the thread, and two, the distance between, say, a number of threads. So pick 4 or 5 and we take that number, and then we compare that to that black bolt we have from the Quaddiction website. If I can go back to that image that I saved. So we get the thread diameter and again the pitch. So knowing the thread diameter and the pitch, we can go into, say, Cura or whatever your preferred G-code converter is, and we can do a scale. So we can then scale the X and Y directions by the thread diameter based on the ratio of diameter of the bolt that we have compared to the Quaddiction bolt. So say we need to shrink it by 80%. So 80% in both the X and the Y, and then the blue, the Z, will be based on the thread pitch. So say again we need to do. So once you print this, I recommend printing the smaller version that you made through your scaling factors, and then afterwards you can go and test that in your gusset. So you can test that in your gusset. So once we have that, that's fine, but there's one next step. We need to put a hole in it. So what we will do is we will go into, we actually have the gate, so we will measure the shafts, the, I guess, fiberglass shafts for their diameter. And understandably, if you know your printer well, you might want to give it some slight tolerance when you've set the diameter. But then we'll go into a tool that basically everyone in Windows 10 should have, which is the 3D Builder tool. So, one moment, I'll just get that loaded and I will join you there. So, opening 3D Builder, we can import the same STL file that we got from Thingiverse. And then, based on our scaling factors that we derived with our prints and with Cura, we can then shrink the model by the same amount in the same axes. So we'll just apply our scaling factors. I'll do these arbitrarily. You can do these on your own. And then we can end up with the smaller bolt. Now, of course, I raised the question before that we need to put a hole through it based on the diameter of the fiberglass shaft. So what we will do is we'll just insert another object. We'll insert a cylinder, just selecting the cylinder on its own. I've just off the top of my head, perhaps it was 8 or 9 millimeters. We can make that to suit. I'm just doing it quickly here just to show you how this would work, and then we will drag and drop and move, and hopefully it snaps to the center automatically. And then we can use some Boolean operations in order to subtract the shaft from the bolt, and then there you have it. We should have the complete bolt, and then we will save as, and instead of the standard format, we'll save it the STL format. And then as you can see here, I already have one saved. So now I will just go back to Cura again with our final bolt, and we should be able to print that and check the result. So now you can see back in Cura we have our fully assembled bolt with the hole in place, and it's ready for final print using the preferred material. Hopefully the same material that you took the initial scaling factors from. As I mentioned, every printer has its slight nuances. So what you should end up with will be the original blank that you used from Thingiverse, and then we also have the bolt that you made. And this should go in straight into the Quaddiction gusset housing, and you should be able to put the shaft right through there. And again, as I mentioned, the sleeve you could attach to the shaft using hot glue. Hot glue has seemed to work for me, and it's also replaceable in case this also breaks. Now, the difference between strength properties, we do have to say there might be some differences. Basically, I advise that you do not tighten this bolt more than what we consider to be finger tight. because the method in which we print, which is one layer on top of another, slowly adding towards the entire model based on the FDM principle, the fused deposition manufacturing, we end up with a spaghetti strand that we wind up along this piece. So what it means is that the flatwise shear strength is not very good, so you could end up with some slight torsion, you could end up twisting it. But what we care about is the strength in these threads, the ability for these threads to shear under compression loads. So what I find that so far I've had no problem. I've also tried doing a few other things, like you could put them in the oven to see if we can consolidate some of the layers better, but that may or may not work depending on what you find. I actually did put in the oven and notice with the PETG that I use, I do get some shrinkage. So again, that would be another scaling step. I would have to first scale based on my printer and then put in the oven and then perhaps scale again and then finally put the hole through it, and that might be long-winded. As I said, it's better to just print it, insert it finger tight, use it. If you notice some weaknesses, improve upon the design, use an alternate material, use an oven cure, whatever you want to do, but you don't have to go to the nth degree until you find out you have a problem. I've been using this for multiple weeks and I have no problems whatsoever, and I'll show you some images of how it all came together. So here we have the final product. As you can see, I have both the sleeve and the bolt made out of PETG, yellow PETG. You can see the fit is quite good. Those calipers work great, obviously. And in the other image you can see, here's the knurled bolt compared to the previous bolt. And you can see that the knurling gives it a bit of class, and it also looks like it's a little easier to tighten. And again, we only want to go finger tight. I also have an image of an oven cure with a baking sheet and a silicone sheet on top, but of course this is if you really have some spare time on your hands, and I don't really have that much at the moment. So like I said, this has worked for me for a couple of weeks, so hopefully you've learned something from this, how to reverse engineer an appropriate fitting bolt for your Quaddiction FPV Gate repair, and hopefully we'll have some more videos in the future. Thank you.